So in this video lecture, we're going to discuss operation of regular languages. So just a review, languages is a set of string from some alphabet. It's a collection of string from our alphabet. It could be finite or infinite. Okay, so for example, we have this alphabet 0, 1, and our language could be X is in alphabet and X contains an even number of zeros. As long as it follows this rule, it will be part of this language. Another example, okay, so our language is from 1 to 9, okay, and the language is X forms a finite length real number. So, and again, any string that conforms with this, it's part of this language. Another example, A, B, C, Z, capital A, B, Z. So X is a Pascal reserved word. So any Pascal reserved word is part of this language. So for example, begin, and if, and other reserved words or other um, command words. And we also have this English word definitely, a collection of words in our English to form a correct English sentence. Okay, so those are some examples of languages. So now let's move on with the different operations that we could implement in our language. So which are union, intersection, difference, concatenation, clean, closure. So clean is represented by asterisk. Okay, so let's start with union. So union, so we have this theorem. If L1 and L2 are regular languages, then the new language L, our new language, is equal to L1 union with L2 is regular. So basically, union is combining all strings from two languages to form a new language. So for example, English and Tagalog, we're going to combine this. We have a new language we call Taglish. Okay, so in this theorem, to prove this is correct, so there is a machine that will accept language 1. So this is that machine. And in language 2, we have a machine that accepts the language of 2. So therefore, either as long as it falls under or it is included in L1 or L2, it will be accepted by our new machine. Okay. And for complement, if L is a regular language, it is complement L is also regular. Going back to our discrete math, if say complement, okay, and based on set theory, so we're talking about universe. So complement of a certain set, it means all elements of that set, excluding all elements of the universe, excluding the element of that set will be the complement. Okay, same as with our language. Okay, going back to this theorem, if L is regular, there is a DFA-M that decides L. And also, if we're going to get the complement of this language, there is a machine that would accept that strings, which is complement of the original language. Okay, so there will be a machine, a complement machine that accepts the complement language, so that it will be regular. Okay, and for intersection, so if L and L2 are regular languages, then the new language L is equal to L sub 1 intersect L sub 2 is also a regular language. So proving this, by the way, intersection, we all know that is the common between sets. So same as with this. So proof, so using De Morgan's law, we're going to complement both side, the language, the new language, and its equivalent. And using De Morgan's law, intersect will become union and separate the negation or the complement. And we all know that complement of a language is a regular. So regular union with regular, definitely it will be regular. So that's why complement of L is also regular. Okay. So concatenation, it means appending our the string of a language to our existing language. Will it be on the front of a string or at the end of the string? Okay, so let's have this definition. So if L sub 1 and L sub 2 are languages, then the concatenation of the two language, which is new language L, is equal to L1 concatenate with L2, wherein the set of all strings of the form x sub 1 and x sub 2. X sub 1 and x sub 2 are element of L sub 1 and L sub 2 respectively. This should be um, present to form the new language. There should be an x sub 1, there should be an x sub 2 to form our new string. Okay, so we have this theorem. If L sub 1 and L sub 2 are regular languages, then the new language L is equal L sub 1 and L sub 2 is regular. So just to prove, so there is a machine that accepts language 1, and when we, okay, and it is connected to another machine, so we could go to the next machine through epsilon transition. It means a language 1 could be either present or not. It could go to the second machine. Okay, and the language 2 will be accepted by machine 2. Okay, and it will be accepted. Same as with if the language 2 is not present in our language, it could be accepted pa rin because of the epsilon transition. So M1 language, epsilon epsilon, it will be accepted, or M1, M2 will also be accepted. Okay, so concatenation, regular language, it will become regular language. Okay, and for clean, it's basically this is our loop. Okay, so if say loop, it means that we are this the length of our string is variable from 0 to infinity. Okay, so it includes no string up to lots of symbols. Okay, so that's the meaning of clean or asterisk. Okay, so that's the end of this video lecture. Thank you for listening and see you next on the next video lecture. Thank you.